When dividing radicals, your goal is to get rid of any radicals that you have in the denominator, okay? So radicals are not allowed to stay in the denominator of a fraction, but they're allowed to be up top, all right? So how do we do that? So to do so, we're going to multiply the top and bottom of a fraction by the same expression, which is going to vary depending on the problem, okay? So here's our first example for A. Now, we've got this radical in the denominator. This is our issue. So how do we make it go away? Well, if I can make that 8x into a perfect power of 4, then I can find the fourth root of it. So the question is, what do I multiply 8x by to get something to the fourth power? That's my goal, all right? Well, if I think about my perfect powers of 4, 2 to the fourth power is 16. So if I can make this into a 16, I can get 2 to the fourth power. So 8 times 2 would make that happen, okay? And then that x needs to become x to the fourth, so I can do 2x to the fourth. So if I multiply that by x cubed, well, if I do this, I'll get 16x to the fourth, which is essentially the same as this, okay? So I want to multiply by what's in the box. So I'm going to multiply by a fourth root. I'm going to multiply by a fourth root. Okay? I'm going to multiply by the fourth root of 2x cubed. Okay? So up top, I'm going to have 3 times the fourth root of 2x cubed. And then the denominator, I'm going to multiply the radicands together. So 8 times 2 is going to give me 16. And then x times x cubed is going to give me x to the fourth. And that's a perfect power of 4 on the inside of that denominator radical. So now I'm going to have 3 fourth root of 2x cubed. And the denominator, the fourth root of 16 is 2. The fourth root of x to the fourth is just x to the first, because I'm doing the 4 exponent inside divided by the 4 index to get x to the 1. Okay. Now, because this was an even indexed root, and this exponent right here is an odd exponent, I need absolute value around that x. Okay, so this is the final answer for problem A. All right. So we have to kind of reason our way through what does the denominator need to become so that I can actually evaluate the radical and just get a perfect power on the inside. So you got to focus on the index and you got to focus on the radicand. All right, let's take a look at another problem. All right, B. I've got to figure out what do I multiply 4 by so that it becomes a perfect cube. All right, now, 4, if I do 4 times 2, I get 8. And 8 is 2 cubed, okay? So if I can get 2 cubed inside the radical, if I can get an 8 inside the radical in the denominator, then I'm good to go. So I'm going to multiply this by the cube root of 2 to get that 8 in the denominator. But what do I do to the bottom? I must also do to the top. Okay, so up top, I have the cube root of 15 times 2, which is 30. In the bottom, I'm now going to have the cube root of 8. And we know the cube root of 8 comes out to 2. Okay, and that's my final answer. I don't have to worry about absolute value because there weren't any variables involved. All right, on to C. Now, this denominator has a radical and a non-radical, okay? The 5 is not an issue, only this is the problem. So I've got to multiply. If I do square root 2 times square root 2, that gives me square root 4, which is just plain old 2. Okay? So what I'm going to do is I'm going to do times the square root of 2 times the square root of 2. Now that's going to give me up top 4 square root of 2. The bottom is going to give me 5 square root of 4. We know what the square root of 4 is. So I really have 4 square root of 2 over 10. Now this is not quite finished though, and here's why. If I take a look at this, these numbers that are on the outside, they can be reduced, okay? I can reduce those. They have a common factor. So I'm going to divide top and bottom by that common factor. So if I divide that by 2 and divide by 2, so divide by 2, divide by 2. I'm going to end up with 2 square root of 2 divided by 5. The inside of the radical will not change, but the outside does, okay? So I'm modifying the numbers outside of the radical. I'm reducing 4 over 10 down to 2/5, and then there's still the radical 2, okay? All right, let me know what questions you have.